Hello, my name is Nadav, and today I'm going to explain to you how our grasshopper code is working. So basically, this is our control panel, what we see here, and the code got two big chunks. So this chunk is all about the starting point. It's a physicist system that works to find for each guest by the Excel data we have here the best starting point, and we'll see how it works soon. And the next part is this part of the voxel, which takes the envelope and the voxels and subdivide them between the guests that are in the hotel in a certain time. So let's see how it works. So first we have here our schedule, and in this area we can choose a day. So now we have day 5. These are the days, this way, from the left to the right, and from up to down is the different figures. Day number 5 means that the third and the fourth figures are in the hotel, for example, and we've got dots for them. So let's choose, for example, day number 10. So as you can see, we have day number 10, and we see on the left that figure 1, 2, 4, 5, and 6, for example, are in the hotel, in the table. So this is the first part. After we have this information, it goes from here to this area, and each figure is being checked if it's in the hotel or not by the system. And all of this information is being unified back into two systems. The first system is the number system, in which we can see we have the number of the figures. And the second system is the binary system, in which 1, 1, 0, 1, 1 representing the figures that are in or not in the hotel. This information is going into this point creation area. As we can see in the 3D area, we have this point creation, which are these points. Each point for each guest, and each point of these we want to take into the physicist system and check by the Excel data which is the best location for each of them. So let's see how it works. First we have to put the Excel information inside. By double clicking here. Okay, now we can see that the Excel information is already inside Grasshopper. And let's go back to this physicist part and see what we have here. So first we have the stay away parameter, which is here in the Excel for each figure, and it is representing the number of centimeters of my closest guest as a starting point for each guest. So this information is being translated here into spring, which is a kind of a force, physical force, and then we have this stain envelope area, which takes this BRAP of the envelope and tells Grasshopper to keep all of the points inside this envelope. And then we have the 3 structural needs here, which are window, ground, and rooftop, and for each of them we have a number 1 to 5 in our Excel for each guest. Representing in the code, we have a BREF or a spatial thing representing each of them. For example, the ground is a BREF that is the building, or for example, the rooftop is a BREF that is above the building. These forces that we make here in this physical system takes the specific point that are interested in the ground floor and pull them in the different amounts by this table towards this BRAP, but they keep them inside the envelope. So let's see how it works eventually. So let's go to the kangaroo grasshopper component and turn it on. And now what we can see is, let's take for example figure number 4. 5, 0, and 5, which means 5 for the window, 0 for the ground, and 5 for the rooftop. You see that the location is right up there with 2 windows and really close to the roof. And really close to 10, which is the closest neighbor, only 100. So this is the first part of the code. Now the second part of the code is all about the voxels. So first we have to freeze the situation to make it easier for my computer. So the second part of the code, as I said, is all about the voxel subdivision between the guests. And so after we have this optimal point, we have these voxels. We want to subdivide them between the guests. So the first thing that we have to choose here is the percentage of usage, which means what is the percentage of voxels that will be in use in this time in the hotel. So here, for example, we chose 85%. Then we take this information and we have to decide how many voxels we can have for each guest. So after we have only 85% of the total, we take for each guest the optimal size of the room, which is another parameter in the Excel. How many voxels are the optimal size of my room? And we take this parameter for each guest, and we check which one is in the hotel and which one is not again. And then we sum up all of the numbers together and we get a number. And then when we divide this number by the number of available voxels we have, this 85%, we get a number of voxels that will be the exact number of voxels in proportion to these numbers in this situation for this specific guest. Now the second idea here is that instead of just taking for each guest only the best location, we want to have a shape for each room. So for having this, we made this row of shapes, and each of them is representing an optimal shape for a room of a different guest from our guest list. And so what we do here in this part of the code is taking all of this information of these shapes and orient them here into these points. So what we get is this result, which is the shapes located already in their locations. Let's delete it for now and go back to the code and see how we choose our voxels for each guest. So the idea here is that we have a level of compromise. The level of compromise is like a row. It's like putting all of our figures in a row and deciding which one will choose the voxel before the other. So for example, we see here that figure 12 got the first number, which means that figure 12 got the highest level of compromise, and this figure will choose the location and the volume first. So what we see here is that we take the shape of the room and we take out of all of our 30 on 30 on 30 voxels, and then the first figure is choosing the best voxels, and we've got a result for that. And then after that, we want to have our leftovers for the others. So we have this leftover thing that have all of the one that this figure didn't use. And then it goes down to the next figure in order, which is figure number 15. As we can see here in the Excel, figure number 15, we got the second one to choose. And it goes like this all the way down, and if the figure is not in the hotel, so it just like jumps over it, and then you have this row of all figures one by one going down and choosing until the last one here is choosing, and then we can see the result when we bake the result here by baking Xerox. So here is the result. We can see that only 85% of the hotel is in use. We can see the different room shapes. That one is like tall and high, for figure number 3, for example, or like a very mountainy one for figure number 1, etc. Okay, thank you for watching. Bye bye.